So on page 27, you guys are going to be talking about three-dimensional shapes. And this time we're talking about angles. The other day, you guys were finding links between different points in your different solids using Pythagorean theorem. And so today we're going to be talking about finding the angle measures between these different points in these respective solids. Okay? So we're going to start off by starting with a prism, finding the different angles that are created with different segments and planes and things like that in a prism. These examples again are going to go on your pink foldable on those 8 or technically the 4 like mini shutters that we created on Tuesday. You know, one on the front and one on the back. Okay, so the front side is going to consist of 4 different cuboids, and we're basically going to mark the angles described. So you will be drawing 4 different cuboids. Great time to get some practice for those who might be struggling. But you're going to draw 4 different cuboids and make sure you label them. I don't know why the D is missing in all these, but D is that that segment right there, or the vertex right there. And when you're calculating angles, you want to identify the right triangles and then use trigonometry, especially when you're working with a cuboid or a prism. Okay. Now, will they always be right angles, right triangles? No, but they will be triangles, and the goal is to try to figure out what angle we are exactly looking for here. So for A, we are going to mark the angle that's described. So for the first one, it says the angle that the plane ADHE makes with line AG. Let's start by drawing line AG here. Okay, and we're looking for the angle that it makes with the plane. Well, the plane is right here, down at the bottom. Okay. That is the full plane. Now, if you're thinking about it, okay, well, I need another segment to create that angle. I wish I could kind of show you this visually. We're basically looking for the angle that this line segment makes with this plane. So if I were to draw it, that's the angle we're looking for. There's the plane. It's touching it right there. It's basically cutting from corner to opposite corner, and then the angle that line creates with the plane. So if you're trying to figure out, well, what is that potential segment that's going to create that triangle? What's that segment right here that goes straight across the plane at AH? And then there's your triangle. And that's the angle that we're looking for, that blue measure right there. Now let's look at the next one. It says the angle that plane ADHE makes with line AC. Well, here's AC. Let's start there. That's the easy part. And now plane ADHE is this bottom plane right here. So we're trying to figure out, okay, what is that angle that that particular line segment makes with that? Okay. Well, if we think about it, it's basically right along that left wall of that cuboid. And so the angle that's going to make with that plane is that angle that is created with this particular line segment there. And there's your triangle. If you need a reference, a good reference would be to look at the classroom. Like, label the classroom vertices with all the points, and then figure out, okay, if I were to draw or like add in a pipe or something that goes from these respective to create like a line AG or line AC, and a plane ADHE represents the ground, what is that angle that that particular line that I'm drawing between these 2 points is going to create with that bottom ground? And as you can see, if you can visualize that, then you'll see that it is that angle here and that angle right there along the wall. Now remember, the key thing is we're trying to create a right triangle here. And so that's why we, when it comes down to determining, okay, exactly how we're going to create the triangle or how we're going to figure out which angle it is, we need to know that, okay, we are looking for a right triangle. So create that right triangle, figure out what segment is it going to be that's going to help you create that right triangle. Let's look at C and D. It says the angle that plane ABCD, so we're talking about the plane right here on the side, makes with segment CE. Okay, well, that plane right here would need to make that angle with this segment here. Okay, and this is the angle that we are talking about right here, the angle that CE makes with the plane. So we're talking about that angle. And here is that right triangle that is formed. lines right there along the side. Okay. And the last one, the angle between BH and HA. This one's actually not too bad because it is two segments. BH and HA, the angle that they create, well, it's right there between those two segments, between those two lines. And then here's your right triangle. Right? It comes with practice creating those particular triangles. You guys will get that practice in your homework. Okay, so those are your first four examples. Let's try it with the pyramids now. Okay, so you're going to be drawing a square-based pyramid. The easiest way is to draw a square, put a dot above it, and then just draw lines that connect to each one of the vertices. You create your pyramid. Make sure that you label as well. Now it says E is vertically above the middle of the base O. Okay, the E is the apex. And because it's vertically above the center of the base, then we know that O is basically creating a 90-degree angle with that plane ABCD. So we're looking at the angle that the base of ABCD makes with the edge DE. So there's DE running right along the edge. And we're trying to figure out the angle that it makes with plane ABCD. If you recall before, we're trying to make it with the plane, we basically need to, consider that, hey, we are probably looking at that line that runs diagonally across from B to D, okay? And I feel like, well, that's not going to be a right triangle. Well, that's very true. However, EO does create that right triangle, and that's what we would use there to figure out the measure of that angle. And so the angle that we're looking for that DE makes with plane ABCD is this angle right here. The next one, the angle that the base ABCD makes with ME, where M is the midpoint of CD. Well, M right there is the midpoint of CD. So let's go ahead and let's label that M. And we are trying to find where CD, ME, so from M to E, makes with the base. So hopefully you would think that, okay, well, we can run straight across the middle. We would keep going, but then that wouldn't help us when creating our triangle now, would it? So then there's their angle right there. And here's the right triangle. And the beauty about some of these IB questions is that you'll be kind of finding out piece by piece. And so more than likely you'll be asked probably to figure out, what is MO first. And then it might ask you, what is the angle that, the base makes with ME. And you'll know the length of EO or something. And then you could use, SOHCAHTOA to help you figure that out. You'll be given some pieces of information that will kind of help guide you to exactly which angle you're going to be looking for. Now, like I mentioned before, will all the angles be right angles? No, not necessarily. Especially like in this case is where it says the angle between BE. Oops, that was not the segment I wanted. Between BE and ED. Well, that angle right there definitely is not going to create a 90-degree triangle because it's basically spanning from edge, going along the edges. And in those particular situations, we probably could use cosine rule or sine rule, depending on the information that we're given. Okay? If we wanted to, yes, we could draw a perpendicular line straight down and use SOHCAHTOA there to find out the measure of just half of that angle and then double it to get the full. But depending on the question, it could very well, give us, BE and ED, and you would have found the length of BD or something like that. Then you want to use cosine rule. Same thing if you're looking for the angle between DE and EC. Again, that's another angle that won't create a right triangle, okay? But you probably will be given the information of BD, and same thing with ED and EC, and then you could use cosine rule or to help you find that angle. Speaking of IB problems, let's go ahead and let's take a look at one. Your first one you're going to put in the middle, like I explained the other day, you're going to put in the middle of your pink foldable. And then you're going to fold up the foldable fluid into your notebook and then do the second example on your actual notebook paper. So here's the first one. So the diagram shows cuboid A, B, C, D, E, F, G, H, or H, E. And AE is 9, AB is 2, and EH is 5. So this particular diagram is not labeled, so you want to make sure you go ahead and label it. And do realize that, you know, AB and a few other segments have a length of 2, EH and a few other segments have a length of 5, and AE and a few other segments have the length of 9, okay? And so it's asking us to calculate the angle that the plane ADHE, so the bottom, makes with line AG, okay? So we're looking for this particular angle. So this is where this stuff like this comes in, okay, us drawing it, because we're looking for this angle right here. The beauty about it is that we're trying to, again, make a right triangle. That's the easiest way for us to do this. So GH is going to be that segment that creates that 90-degree angle for us. That's going to help us solve this problem, okay? Now, we already know that GH is 2. It's the same measure as AB. Now, in order to find this angle, we're going to need at least one more side. We're at least going to need AG, or we're going to need AH. So then that way we can use a SOHCAHTOA. Now, if you look down at the bottom, you will see that AE is 9 and EH is 5. And from our skills from the other day, we can use Pythagorean theorem to find AH. So let's go ahead and let's set that up. That's going to be AH squared is going to equal 9 squared plus 5 squared. And remember, since we are using this to help us figure out the actual answer to part A, we do not want to round. We want the non-rounded answer. So we'll have 81 equals, AH squared equals 81 plus 25, which is 106. And so then AH is going to equal the square root of 106. And so now that we have that piece of information, we can do SOHCAHTOA to help us figure out the measure of the angle. Okay. Now, if I was on my normal, board, I would, draw out the triangle, and then, kind of show you that, okay, this is the opposite side, the adjacent side, the hypotenuse, to help us figure out the value of that angle. But hopefully you guys can see in the pink that 2 is your opposite side, and the square root of 106 is your adjacent, and so we are going to be using a tangent here to figure out the measure of that angle, which I'm going to label GAH. That again is going to equal 2 over 106. I'm sorry, the square root of 106. And then again, whenever we're looking for an angle, we need to do the what? We need to do the inverse. So we're going to take the inverse of that, and we're going to get our answer. And we'll get our angle measure of 10.993 degrees, but then we'll round that to 3 significant figures to get 11.0. Now again, in these particular situations, yes, you would put the 0.0 because we had to round it up to get the 11 degrees. And now to answer B, it says calculate the angle between BH, which is the purple, and HE. So we're looking for that angle right there. Use a different color. I'm going to use purple and match it. So for this angle right here. Okay. Now we are in a cuboid. This does create a right triangle. If we connect E to H together, we have a right triangle right here. We know the length of EH, which is 5, but we do not know another side length in order for us to find that angle right there at the top. However, if you see triangle BAE does create a right triangle. And so we can actually find BE by using Pythagorean theorem again with the triangle lengths of 2 and 9. And then BE is our hypotenuse. So we can find that out by doing BE squared equals 2 squared. That's 9 squared. That's 4 plus 81, which is 85. So BE equals the square root of 85. And then we can label everything again. The square root of 85 would be our adjacent side, and 5 would be our opposite. So we would have another tangent to help us find the measure of HBE. And that would be 5 over the square root of 85. And then we would do another inverse, because again, we're looking for an angle. Whenever we're looking for an angle, we do the inverse. So that'd be the tangent inverse of 5 divided by the square root of 85. Again, we don't use the decimal approximation because we want exact answers here. We want to round only on the final answer. And then that's going to give us 28.47, which rounds up to 28.5. And then that's how you use the segments within cuboids to find different angle measures with between different points or segments or planes in three-dimensional solids. For this one, I want you guys to go ahead and give it a try. Label all your sides. Get the question down. Label all your sides. Remember, this one is going on the notebook paper. So go ahead and fold up the foldable like how I showed you the other day. And then pause this video, try this problem out, and then when you're ready to see the answers, press play. So in this one, you have the diagram shows the right pyramid, A, B, C, D, E. The base is a rectangle and gives you the measurements. And the height of the pyramid is, if the height of the pyramid is 7, then you know that that's what segment EO represents. So we have to calculate the angle of AEO. Okay? This is actually pretty straightforward. AEO, that is the segment that we have here. I'm sorry, not the segment, I'm at the angle, just this angle right up here. Let's go ahead and let's create our right triangle, because since O does make a 90-degree angle with the center, we do have our right triangle where we know EO is 7. We don't know AE, and we don't know AO. We could find AO by doing the Pythagorean theorem with triangle ADC. Again, that's triangle ADC. If we could find the length of AC, all we would have to do is cut it in half to find the value of AO. So 6 squared is 36, 4 squared is 16, 36 plus 16 equals 52. So then AC would equal the square root of 52. So when we divide that in half, that would be 52 divided by 2. Again, we don't really want the decimal approximation because we're going to be using that to actually get our final answer. So when we're looking for this angle, let's label the sides real quick. This would be our adjacent side, and then AO would be our opposite side. So adjacent and opposite would give us tangent. So the tangent of angle AEO would equal our opposite side, which is basically AC, and we would divide up our adjacent side, which is 7. Again, we are looking for the inverse of tangent, so we're going to do the tangent inverse of AC, that length, divided by 7. So this is when we go into our calculator. Okay, I'm just going to go ahead and I'm going to do the square root of 52. I'm going to divide it by 2. I get my answer. I'm going to go ahead and take the tangent inverse of that answer, AC, and then divide it by 7, close my parentheses, to get my final answer, which is 27 point, rounding 3 significant figures, 3. So AEO equal to 27.3 degrees. That is our answer to A. Now to find the answer to AC, we are going to use, there is AE, and then E to C. And if you notice, that segment actually is twice, not segment, that angle is twice the angle we just found. So to find AEC, the measure of AEC, all we do is we just double the measure of AEO. And since that is just sitting in our calculator, all we have to do is just multiply this answer by 2. That way we don't have to worry about rounding anything. So then our answer is going to be 54.5 is going to be the measure of angle AEC. And that's the angle that we round. Now we're told that M is the midpoint of a CD right here. Let's go ahead and let's label that M. And we would know, since that's the midpoint, DM would be 2 and MC would be 2. So now to find the measure of the length of ED, okay, we have ED. We'll look for that length there. Okay. We could actually do another Pythagorean theorem using OD and EO. That's another right triangle. And considering we do know the value of OD, OD is the same length as AC, because BD would be another Pythagorean theorem with 4 and 6. So we get the same thing, the square root of 52. And OD is half of that length, so AO, go ahead and type that out. Change colors here. AO is equal to OD. And so knowing that, we can use Pythagorean theorem to find the value of ED. ED is another hypotenuse. And that would equal, I'm just going to type it out just in case anybody's confused. And so we have 7 squared plus the square root of 52 over 2 squared. And we will get when you square a square root, square root goes away. And when you square a fraction, you not only do you square the top, but you also square the bottom as well. So that's what you end up getting. Now 54 plus 52 over 4 is, off the top of my head, I'm not quite sure. It's actually a whole number, 62. So then ED is equal to the square root of 62. And our answer is 7.87. And don't forget our units, which are centimeters. Now it tells us to calculate, let's do easy square if possible, the measure of angle DEC. So looking for this angle right up here. Okay, this is definitely not a right triangle. However, since it did tell us, I don't know if anybody noticed that, but it did tell us that M is the midpoint of that segment. We can actually use that to create a right triangle. Okay, so I'm going to draw it over here just so everyone can see it. It creates a right triangle. where M is the 90-degree angle, E is the angle at the top, and D is the angle at the bottom. Right, we already know that DM is 2 because it's half of 4, and we just found out that ED is the square root of 64. I'm sorry, 62. Okay, and now we're looking for this angle right up here. So if we can figure out what this angle is, all we have to do is double it to get our final angle. So this is going to be our opposite side. The square of 62 is going to be our hypotenuse, and so we're going to use sine here to find the measure of angle DEM. That's going to be 2 divided by the square root of 62. We are going to do the inverse of that. And then we're going to type that into our calculator to get our answer. Now to find the actual answer of what we're really trying to find, which is angle DEC, all we have to do is double the measure of DEM. So I'm going to do two things in one. I'm going to do the sine inverse of 2 over the square root of 62 to get us the measure of angle DEM, and then I'm going to double it. So sine inverse of 2 divided by the square root of 62. That's the angle. Now I'm going to double it. And that's my final answer of 29.4. And that would be degrees. And that is how you can, again, use triangles to help you find the measure of angles. Okay, still, it's right triangles. You guys use Pythagorean theorem to find side lengths. Use SOHCAHTOA to help you find angles. Yes, you could have used a cosine rule at different points. You could have used sine rule, but you know, if it's a right triangle, use SOHCAHTOA to save you some time. All right, your homework is going to be online. You guys do have a Thanksgiving break assignment as well that you should have received from the sub. If you're not going to be here on Friday, if you are going to be on Friday, then you'll get it on Friday. Other than that, if you have any questions, please feel free to contact me.